So if we start with this question, which is asked in 2025 only, let's see how the concept of Pythagorean triplets help to solve this problem. Here you have to notice that a less than b and then a square plus b square equal to 2025. 2025 is nothing but a perfect square number. That's why we dare to solve it with the help of concept of Pythagorean triplet, because 2025 is nothing but 45 square. They may not be primitive Pythagorean triplets. So let's start with a equal to d into m square minus n square, b equal to 2dmn, d is the common multiplier, and c equal to d into m square plus n square. Now, if you analyze the right hand side, this right hand side is of the form c square. C square means d square into m square plus n square whole square. So in 45 square, if we try to express this as in this form, d square into m square plus n square, then we get one immediate solution. Okay, so how can you write this? You can write this one as 5 square into 9 square. Okay, so this 9 is not sum of two squares. 9 is never can be m square plus n square form. But m square plus n square form, we can write this one, this 5. Why? Because m equal to 2 and n equal to 1. Okay, one of them is even, the other one odd, and you can get m square minus n square, all these things. So what is d going to be here? D is equal to 9. If d equal to 9, then let's find those numbers. A equal to d into m square minus n square, 9 into 2 square minus 1 square, that is 9 into 3, that is 27. And what is b over there? That is 2dmn. This is equal to 2 into 9 into 2 into 1, that is 36. And the value of c is going to be d into m square plus n square. That is 9 into 2 square plus 1 square. That is 45. Okay. Now 27 less than 36. So we can get easily the answer that three triplets are of the form 27, 36 and 45. Now we have a question. How do you know that this is a unique solution? Should I say that this answer is correct? My argument is that this is perfectly alright, because when you are not able to express in the form m square plus n square that into d, I mean right hand side is in this form, d square into m square plus n square, then it is not possible. If you write maximum this 45 square, you can write this manner, that 45 square equal to 3 square into 15 square. See, if you take d equal to 3, then m square plus n square equal to 15. It must be. But 15 is not sum of two perfect square numbers. Okay, so this is the only solution. I tell you, this is the easiest solution. But if this kind of question arises in descriptive part, then you have to take extra care to prove the uniqueness of this equation. This is a Diophantine equation. Always you get solution in integers, positive integers. See, Pythagorean triplets, that Euclid's relation. No, that relation first. This is a type of Diophantine equation where you get positive integral solution. So positive integral solution will be unique. Maybe extra step demanded when you are doing it in descriptive part. You might have to show that the solution is unique over there by using the congruency modulo. Divisibility by 3 or 5 can help you. Okay, but for MCQ, we will not waste time this much. And this I have proved that this is unique because by the use of concept of Pythagorean triplet, we can get the solution very first here. This question I found in ISI 2018 descriptive paper. How to solve this one? And why am I doing it? With the help of Pythagorean triplet only. See, the Euclid's formula in Pythagorean triplet is a powerful tool to solve some problems from Diophantine equation. So, can it be considered as that? Of course, because ABC belonging to N. All those natural numbers are there. So, we should try this one with the help of concept of the Pythagorean triplets and their properties. Maybe primitive, maybe constant multiple of the primitive Pythagorean triplets. Okay. So let us start this one first by saying that the relation they have given is first a square plus b square equal to c square. Okay. You know, A and B, they have different parity. One of them is even and the other one is odd. They all belonging to set of natural number. Here it is given that c minus b equal to 1. So why should I not approach with the help of concept of Pythagorean, primitive Pythagorean triplet? Of course we'll try because c minus b 1 and they have different parity. Then one of them must be even and the other one is odd. And c is always greater than b, as c is always greater than b and B and C have different parity. So C minus B to be 1. 1 is odd number. This is possible. C is an odd number and B is an even number. Okay. As C minus B equal to 1, it has to be true. Now, taking C as an odd number and B as an even number, we can easily prove A is odd. How? Because from this given relation that A square equal to C square minus B square, we write this as C plus B, C minus B. C minus B is 1. So therefore, A square equal to C plus B. Now C and B, they have different parity. So this implies that A square is odd. You understand? Because C odd and B even. So A square odd. What does this imply? A is an integer. As A belongs to N. So this relation will imply that A is odd. Clear? You got A is odd. So first part is done. And this is enough in descriptive paper even. Now we are going to prove that B is divisible by 4. How to prove it? B is divisible by 4. See, A square plus B square equal to C square and C equal to B minus 1, C minus B equal to 1. And now we got A square is odd. Odd means we can take it in the form, A square can be taken in the form 2k plus 1. Okay, always you can take this form if required. Now, what do you get for B? Using A square plus B square equal to C square, and the value of C is what? Value of C is B plus 1 whole square. Okay, so this implies that a square equal to b square 2b plus 1 minus b square. So this is going to be 2b plus 1. So this implies b equal to a square minus 1 by 2. What you are supposed to prove? B is divisible by 2. Now, you have taken a square 2k plus 1. But we can take a also 2k plus 1 because we have claimed that a is odd. So, I'll go by that only. Let a equal to 2k plus 1. Just substitute here. It is 2k plus 1 whole square minus 1 by 2. So, this is 4k square, 4k that divided by 2. This is going to be 4k, k plus 1 by 2. So 2k into k plus 1. What does it mean? B is 2k, k plus 1. K is an integer. K belongs to k itself belongs to n, set of natural number. You can say that this whole number, that they have given natural number, so we start with this. A equal to c. Less than that, not possible. Because we are running the concept of primitive Pythagorean triplet. K should belong to n, k cannot be equal to 0. So what do you get here? B equal to 2 into k plus 1. K into k plus 1 must be even, they are consecutive integers, must be divisible by 2. Therefore, B is divisible by what? 2 into 2, that is equal to 4. Clear? Hope you have understood. This third part looks a bit difficult, that you have to prove a to the power b plus b to the power a is divisible by c. This is a brilliant problem, believe me, because suddenly a to the power b to the power a is a huge term. So how can I proceed? And you are solving a problem which is in number theory. Better to say, this is an example. Always Pythagorean, those natural numbers obeying the relation a square plus b square equals c square. In your mind, it will play that you are solving a Diophantine equation always in positive integers. Those solution of ABC always will be positive integer. Now, let us see one thing, that when you are going to solve number 3, what is the value of a? A to the power b plus b to the power a. That b you got in the form 2k plus 1. And b is what? B is c minus 1. Before this, you got another relation, that a square is 2b plus 1. Now, let me start with a square first. That a square we can write as c square minus b square, c plus b, c minus b. They have given 1. So, this is c plus b. And b is what? C minus 1. So, a square is c plus c minus 1. 2c minus 1. Okay? So, a square in this form, that is 2c minus 1. You have proved that b is even. Now, let us try to evaluate a to the power b. A to the power b is what? That is a to the power 2k into k plus 1, a square to the power k into k plus 1. That a square you have written in the form 2k minus 1. 2k minus 1 to the power k into k plus 1. Okay? Or better you write a square is, this is actually 2c minus 1. 2c minus 1 k into k plus 1. Okay? Let us go for b to the power a. B to the power a going to be what? Just see b, what have you got b? B is c minus 1. So c minus 1 to the power a. And a is what? A is odd. So this is c minus 1 to the power 2k plus 1. I mean, if you take odd number in the form, say, I have used k over there. If you take a equal to 2m plus 1, then it's fine. So you put it over there, 2m plus 1. So this is nothing but c minus 1 to the power 2m plus 1, it's binomial expansion. Okay? They have asked you to prove a to the power b plus b to the power a divisible by c. I have got everything. I mean, a to the power b and b to the power a in terms of c. If this result divided by c, then it will give you, this will give you minus 1 mod c. Agree or not? Because 2k minus 1 to the power, no, this will be plus 1. Because k into k plus 1 is even. K into k plus 1 consecutive integers, there one of them must be divisible by 2. So this is plus 1 to the power. I mean, if you write the last term, all other terms, if you go by binomial expansion, all other terms divisible by c, only the last one. But last one is minus 1 to the power k into k plus 1. But k into k plus 1 is even. So this is nothing but 1 mod c. And what about this one? If you go by binomial expansion of this one, then it will give us, this is equal to minus 1 to the power 2m plus 1 mod c. This is congruent with minus 1 mod c. Okay? So a to the power b plus b to the power a is what? 1 mod c minus 1 mod c. This is going to be 0 mod c. So what conclusion you make? Therefore, c divides a to the power b plus b